Chapter 10. Introduction to Data Mining. Data mining is focused on better understanding of characteristics and patterns among variables in large databases using a variety of statistical and analytical tools. It is used to identify relationships among variables in large data sets and understand hidden patterns that they may contain. XLMiner software implement many basic data mining procedures in a spreadsheet environment. The scope of data mining. Data exploration and reduction. Identifying groups in which elements are in some way similar. Classification. Analyzing data to predict how to classify a new data element. Association. Analyzing databases to identify natural associations among variables and create rules for target marketing or buying recommendations. Cause and effect modeling. Developing analytic models to describe relationships between metrics that drive business performance. Data exploration in XLMiner. XLMiner ribbon. XLMiner can sample from an Excel worksheet. Example 10.1, using XLMiner to sample from a worksheet. Click inside the database. Select variables and move to right pane. Choose sampling options. Example 10.1, using XLMiner to sample from a worksheet. Results. Data visualization. XLMiner has the capability to produce box plots, parallel coordinate charts, scatter plot matrix charts, and variable charts. These are found from the Explore button in the Data Analysis group. Example 10.2, a box plot for credit risk data. In the second dialog, choose months employed as the variable to plot on the vertical axis. In the next dialog, choose marital status as the variable to plot on the horizontal axis. Click Finish. Parallel coordinates chart. A parallel coordinates chart consists of a set of vertical axes, one for each variable selected. For each observation, a line is drawn connecting the vertical axes. The point at which the line crosses an axis represents the value for that variable. A parallel coordinates chart creates a multivariate profile, and help an analyst to explore the data and draw basic conclusions. Example 10.3, a parallel coordinates chart for credit risk data. In the second dialog, choose checking, savings, months employed, and age as the variables to include. Scatter plot matrix. A scatter plot matrix combines several scatter charts into one panel, allowing the user to visualize pairwise relationships between variables. Example 10.4, a scatter plot matrix for credit risk data. In the next dialog, check the boxes for months customer, months employed, and age and click Finish. Variable plot. A variable plot plots a matrix of histograms for the variable selected. Example 10.5, a variable plot of credit risk data. In the next dialog, check the boxes for the variables you wish to include and click Finish. Dirty data. Real data sets that have missing values or errors. Such data sets are called dirty and need to be cleaned prior to analyzing them. Approaches for handling missing data. Eliminate the records that contain missing data. Estimate reasonable values for missing observations, such as the mean or median value. Use a data mining procedure to deal with them. XLMiner has the capability to deal with missing data in the Transform menu in the Data Analysis group. Try to understand whether missing data are simply random events or if there is a logical reason. Eliminating sample data indiscriminately could result in misleading information and conclusions about the data. Cluster analysis. Cluster analysis, also called data segmentation, is a collection of techniques that seek to group or segment a collection of objects, observations or records, into subsets or clusters, such that those within each cluster are more closely related to one another than objects assigned to different clusters. The objects within clusters should exhibit a high amount of similarity, whereas those in different clusters will be dissimilar. Cluster analysis methods. In hierarchical clustering, the data are not partitioned into a particular cluster in a single step. Instead, a series of partitions takes place, which may run from a single cluster containing all objects to n clusters, each containing a single object. Agglomerative clustering methods proceed by series of fusions of the n objects into groups. Divisive clustering methods separate n objects successively into finer groupings. Hierarchical clustering may be represented by a two-dimensional diagram known as a dendrogram, which illustrates the fusions or divisions made at each successive stage of analysis. Agglomerative versus divisive clustering. Distance measures. Euclidean distance is the straight line distance between 2 points. The Euclidean distance measure between 2 points. Agglomerative clustering methods. Single linkage clustering, nearest neighbor. The distance between groups is defined as the distance between the closest pair of objects, where only pairs consisting of one object from each group are considered. At each stage, the closest two clusters are merged. Complete linkage clustering. The distance between groups is the distance between the most distant pair of objects, one from each group. Average linkage clustering. Uses the mean values for each variable to compute distance between clusters. Ward's hierarchical clustering. Uses a sum of squares criterion.